All right, eighth graders, today we're taking a look at lesson 8, linear equations in disguise. And if you've been loving the equations that we've been solving recently, you're going to really love these because they're pretty cool. The target goals for today are that you'll be able to rewrite and solve equations that are not obviously linear equations using properties of equality. All right, these first couple examples you are not going to have in your book, but once we do get into your book, we're on page 71. So this first one says, some linear equations may not look like linear equations upon first glance. A simple example that you should recognize is something like this. Okay, so as we take a look at it, we have to ask ourselves, what is it? And then how do we solve it? Well, looking at it, hopefully you notice that it is a proportion. We're comparing x over 5 compared to 6 over 12. How do we solve it? There's a couple ways we can. Well, looking at this, how do we get x by itself? Well, right now, we are dividing by 5, right? So we could multiply both sides by 5. We're going to do that inverse operation. When we do that, our 5's cancel, leaves us an x. And then we have over here on the right side, no different than 5 over 1. So 6 times 5 is 30. And 12 times 1 is 12. If we wanted to, we could have also have reduced this automatically and said 6 goes into 6 once and 6 goes into 12 twice. So that when we reduce this answer, we would get the same thing. We would get a 5 over 2. Because we notice up here, this we could divide by 6 and divide by 6 and still get 5 over 2. Okay, so that is the first way. But the second way I find the coolest. You're going to love it. So we're going to go ahead and start again with x over 5 equals 6 over 12. And we're going to do bow tie. We love bow tie, right? So we're going to go 12 times x and drop it down and get 12x. And then going the other direction, up and down, and we get 5 times 6, which is 30. And now how do we get our x by itself? Divide both sides by 12. So x equals, and it's the same thing. We're going to reduce it. So it's going to end up being 5 over 2. Right? Bow tie is super fun. I love it. All right, next problem. Example 1, again, you don't have this in your book. Okay, so let's just follow along. Notice that since we have x's on both sides now, it's not like we can just get rid of like the 2. We have to do both of them. So bow tie is going to be by far the easiest. Okay, so let's go up and down. Since this x minus 1 is all on the top, that's our quantity. So when we multiply it, we're going to have 4 times the quantity of x minus 1. So do you see how I had to put that in parentheses? So I'm going to have to do the same thing over here when I go the other direction. Drop it down. And I'm going to have my 2 times the quantity, x plus 1/3. Okay, now we can just go ahead and distribute and solve. So we have 4 times x, 4x, 4 times negative 1, negative 4. And then the second side, 2 times x is 2x, and 2 times 1/3 is 2/3. Now, if you don't like this fraction right here, you could get rid of it, but the way you're going to have to get rid of it is a little bit different. Remember these brackets we did? Notice all of these have denominators of 1, but this one has a 3. So if we want, we could multiply everything by 3, which is really 3 over 1 when it comes to cross-canceling with this one. And then we could just distribute that one. So 3 times 4x is 12x. And 3 times negative 4 is negative 12. And 3 times 2x is 6x. And 3 times 2/3, our 3's end up canceling, just leaves us 2. Now we can solve just like normal. Our smaller x we need to subtract from both sides. And now I get 6x minus 12 On the right side, that cancels, leaves me a 2. How am I getting my x by itself? I'm going to add 12 to both sides. So now I have 6x equals 14. I think I am off. I'm going to write this up here because I think I'm writing off of your paper. Divide by 6, divide by 6, so x equals, and if I divide both of those by 2, I get 7/3. And hopefully I'm not too far off of your paper. I'm sorry, guys. Off of my paper, I guess, is not really yours. All right, so let's go ahead and let's look at the next one. Again, this one you do not have on yours. So I'm going to go ahead and move this up a little bit. All right, let's go ahead and start distributing. Remember that this right here has to stay together and this has to stay together. So as I go to do it, ready? I'm going to go up and drop it down as my bow tie. 3 times 1/5 minus x equals, now we're going to go the other way, go up and down, 7 times 2x plus 9. Now we get to distribute. 3 1/5, or 3 times 1/5 is 3/5. And 3 times negative x, negative 3x. On the right side, 7 times 2x is 14x. And 7 times 9 is 63. Now, unless you like this fraction, let's get rid of it. Okay, I would much rather get rid of it than work with fractions. But if you love fractions, you are more than welcome to continue working with fractions. What I'm going to do is I'm going to take this whole thing and I'm going to get rid of that fraction of a 5 because all our denominator of 5, not fraction. All of these had a denominator of 1, so the least common multiple is a 5. So we're going to multiply by 5. When we do that, our 5's right here are going to cancel, leaving me just a 3. Then 5 times negative 3x is negative 15x. And then I have 14x times 5. Well, 5 times 14 is 70. Is that right? 14 times 5. Yep. 70x. And then I have 5 times 63, which is 315. Now I can start putting things together. I'm going to go ahead and move my smallest x value to the other side by adding it. And then I'm going to get 3 equals 85x plus 315. How am I getting it my x by itself? You got it. Subtract 315 from both sides. On the right side, I still have 85. On the left side, I have a negative 315 and a positive 3. So it's negative 312. And I forgot my x right here. Divide by 85, divide by 85. I'm going to move it on up here. So I have negative 312 over 85 equals x. Now I can see that 3 can go into those for sure. I bet there's something else can. Well, let's go ahead and do, no, 3 can't. Well, let's go ahead and leave it, I guess. All right, let's go ahead and look at example 3, which is in your book. So page 71 of your book. And let's go ahead. We're going to bow tie 8 times 6 plus x. And going the other direction. Now, which one of those do I want to write first? Do I want to write this quantity first or the 3? Yeah, it doesn't make a difference. I'll show you this time what it's going to look like if we do it what I would consider backwards. We still would have that 3 and it's going to have to distribute. I just have it written after the parentheses instead of before it like we're used to. So if you like it before it, you just put the 3 here in front. I normally would do that, okay? So right now we have 8 times 6, which is 48, and 8 times x, which is 8x. Now I have to come from the back. So 3 times 7x is 21x. And 3 times 2/3, our 3's would cancel, just leaving us 2. Move our smaller x, which is 8x. So we're going to subtract it from both sides. I now have 48 equals 21 take away 8 is 13 plus 2. Now I'm going to have to get rid of that 2, subtract 2 from both sides. So I now have 46 equals 13x. Divide by 13. Divide by 13. So x equals 46 over 13, and it does not reduce because 13 is prime. Easy, right? It's super fun. All right, let's do this one. Ready? All right, let's go ahead. Bow tie. Look at this. This one's really easy because it's a 1 times that. So I really don't even have to write the 1 because 1 times any number doesn't change it, right? It's the identity property. So we're going to have 3x plus 9 on the right. And then going the other way is 8 times 7, which is only 56. Easy to solve this one. What am I going to do? You got it. Minus 9 from both sides. So I now have 56 take away 10 is 46, but add one more on, 47 equals 3x. And I'm going to divide by 3, divide by 3. X equals, and we cannot reduce it. And we'll just leave it like that. Can't reduce because 3 is a prime number and it doesn't go into 47. All right, this is the last one we have to do. In this diagram, we know triangle ABC, here it is over here, is similar to A prime, B prime, C prime. Using what we know about similar triangles, we can determine the value of x. So as we go to set this up, remember, we start with 1. I'm going to start over here. So we're going to write x minus 2 compares to, so we have AB here, compares to A prime, B prime. Do you remember doing this? And that's going to equal AC, which is x plus 2, compared to A prime, C prime, which is 12. And now we're just doing exactly what we've been doing. So let's go ahead and set up bow tie. We need to do 12 times the quantity, x plus 2, so 12, and then x plus 2, minus 2 in parentheses. And that's going to equal, go the other way, 9.5 times x plus 2. All right, let's distribute. 12 times x, 12x. 12 times negative 2, negative 24. And 9.5 times x is 9.5x. And 9.5 times 2, well, 9 and 9 is 18. And then a half is one more, so that's 19. And now which is our smaller x? We're going to have to subtract 9.5x from the right side and subtract it from the left side. Now when we do that, if we take 12, take away 9, we get 3, but we still have to take away another half. So don't accidentally add on the half, make sure you subtract it. So 2.5x minus 24 equals 19. Add 24 to both sides. So now we have 2.5x equals to 24, 34, 44 minus 1, 43. And as we go to solve this, we're going to divide by 2.5 and divide the right side by 2.5. And I'm going to go over here, guys. Sorry. So now we have 43 over 2.5 equals our x. Now, that's just telling us what goes into there. We still have to plug that in. So when we know that this is the answer, if we would actually divide this out so that we can plug it in, 43 divided by 2.5 is 17.2. So now when I fill that in, 17.2 minus 2 is 15.2. So AB, line segment AB, is 15.2 centimeters. And as I go to this one down at the bottom, we put in that 17.2 and add 2. So we would get 19.2 centimeters for line segment AC. Look at that. We're done. Head back to the classroom.